I can hear you. Yes,
Okay.
sir.
Alvin, I'm not able to hear you, by the way, but yeah, that's fine. So our course is Computing Applications in Mechanical Engineering Technologies. It's me, Dr. Raf Teloni, and this is the book we choose for you. It's a fancy, modern book. I believe it was published in 2019 or 2020. So I'm the one who selected this book for you because we will be focused in computational methods on MATLAB in specific. And this book is designed in a kind of a college style, and it is targeted in the same time for engineers and scientists. So hopefully you'll have fun with this course. Um, As an introduction, in this chapter, we will learn together what is the computational methods. What do we mean by computational methods? And what is the importance of computations for engineers? Like why this science is important for you to learn. If you call it science or you can call it as a tool, why is it important to you? Then we will go through a little bit about the types of computations. What kind of computations does the engineer go through, or why they need those softwares for what kind of computations? Then we will talk a little bit about the softwares available for engineers and for engineering computations in general. Then we will talk a little bit quickly about an introduction to MATLAB. So if I would ask before we move to the next slide, what do you think about computational methods? When you hear the word, let's say you never had a course about computation, I assume. What would you learn, or what's in your mind when you hear the word computational methods? Just anything, don't be shy. Just say whatever you. Nobody will tell you,
I think
hey.
of Navisworks. It's a design program we use building the ships offshore. You ever heard of Navisworks?
Not really. Maybe, probably it's an older than me program.
Probably.
But I heard of
It
SolidWorks. I heard of Pro Engineer.
yeah, it's a naval architect programming where you do all your computations for structural engineering.
So that's like kind of analysis for 3D designs.
Yes, sir.
How about if you have calculations or matrices? What softwares did they
They
use?
they have side programs within that you can do all your calculations and then transform them over to the 3D models.
Cool. How about you, Jordan? What do you think about computational methods? When you signed up for this course, what attracted you? Is that something you just want to take because of your plan of study, or let's say, what do you think? What comes to your mind in computational methods?
I really am not so sure.
Yeah. So it's a computation. It could be some kind of, you gotta do calculation somewhere, and then methods, probably new methods to do calculations or do math. Anybody else
Just
wanna? Yeah, go ahead. Sorry.
just to elaborate on that engineering program that we use, it's more this class I'm hoping will show me how that works instead of just knowing how to use it.
Yeah.
You know what I mean?
Yeah.
That's what I envision with this class. At least minor. It's obviously just a beginning, but
Yeah. Yeah, well, for sure, we will touch base on how things are working through, we will have MATLAB as the main example because, as I told you, as you're going to see in the coming presentations, each program have a different kind of style, different basis, and different purposes. So we're going to for sure talk about MATLAB, how does it work in the background, maybe touch bases on some of those points as moving forward. And we will discuss as well that you're gonna need MATLAB, but what version of MATLAB it is, we're gonna talk about it shortly. Now, computational methods, if you wanna define the computational science, it is known as, in some places, as scientific computing or scientific computation. It is field of mathematics. It uses advanced computing capabilities so that you can understand and solve complex problems. Some problems you can solve it, let's say mathematical problems, you can solve it by hands, like 1 plus 1 equals 2. Why would I bring the calculator? Same concept as your calculator. Why would I bring it to know what's 1 plus 1? I already know it's 2 and it came to me fast. No need to waste time. But if I give you, let's say, 1,000 numbers, you want to combine them together like addition, and you get the final results, then you would start to look into things. You can do it yourself by hand, but maybe it's going to take you longer time to find the final answer. Then you have your, as they call it, operator error. You're going to be distracted. Maybe you miss a number. Then you get a final result being sometimes mistaken, or it doesn't worth your spent time on it. So that's the simplest form of why we need computational methods, so you can find final results faster. In some cases, it's impossible to be done by humans, or it will take them thousands of years, which is not logic to go through these computations. In other times, you need it because you want to save time. Why would I spend time calculating, like let's say, let's combine the numbers from 1 to 100, 1 plus 2 plus 3 plus 4, and so on. So we look into computations. Sometimes we look into the earlier version of before the digitization is, it's like the factorial, you know, like 3 factorial is 3 by 2 by 1. So instead of doing that kind of thing by hand, you know, by factorial how much it will equal as a result. So, you know, computational methods, it depends if you're looking into computations in structure or in 3D design, or you need computations, pure mathematical computations, or you need physical computation. But we can say the modern computational methods can be split into numerical analysis. So you do a certain analysis based on numerical numbers and theories. Then you can do numerical differentiation, like you can use a certain numerical method to solve differential equation in some cases. Then you can use other newly algorithm as known as greedy algorithm. You can use computational intelligence. You hear today about artificial neural networks. You hear about artificial intelligence and implying that into businesses and solutions so that he can solve stuff for you that will take you years and years to find the final answer. By the way, this kind of hierarchy in red, you're not required to, it's not in your book, you're not required to memorize that, but it's just a way to let you see the big picture of computational methods. Now, what is the importance of computation? We already touched that a little bit. Firstly, you need to solve complicated problems that can't be done by hand, as we just mentioned. Then sometimes you have a lengthy calculation you gotta solve, so computation and machine can come in and solve it for you in almost no time. And you need as well to use computational methods to analyze complex systems through a set of constraints. What does that mean? Like sometimes you have, let's say a box. This box is on a table. As you understand probably from some physical courses, there is some forces on that box. There is the weight, the gravitational force, there's a friction force. Maybe the box on a table and the table on both sides have walls. So the box is not gonna move right or left, but he gonna fall on X or Y direction and so on. So you have a certain constraints that are playing a role in the system. As we're moving forward with the course, you'll understand what does constraints means in case you never heard of it before. But it is things preventing the object from doing a certain behavior, or a set of rules that prevent you from doing a certain mathematical calculation in a certain way. So you are only left over with a one way or two ways and so on. Then it will save us in general time and effort. Now, what types of computation we have today? So we have mathematical computations, and we have physical computations, we have chemical, geometrical, and statistical. Mathematical, we already said it's as your calculator, but like it's in a more advanced way. So you can use a set of rules to solve a set of equations, or to do addition, subtraction, division, and multiplication for you for unlimited number of unlimited amount of numbers. For the physical, sometimes, as we just mentioned, there is a box on a table that have a certain constraints. Then you want to see what is the physical properties for the certain equation. Let's say you have the equation of the total force. What is the value of that total force equation? Or let's say we are calculating acceleration, we are calculating distance, displacement, and so on. All those physical properties can be solved through computational methods. It could be different softwares to be used, but it all dragged down into one single point where there is equations and constraints, and there is some calculations happening in the background through the power of the computer. Basically, that's the whole point of computational methods. Of course, computational methods can go complicated, it can stay simple. As we move forward with the course, we will discuss in more details about it. It's just an introduction here to give you kind of a glimpse about the course and where it's going. As we're moving in lectures, you will be more focused on how to use Matlab. Then within the Matlab, after we feel familiarized and feeling comfortable using the MATLAB and it's in our machines, we'll be able to take examples and solve them right away into the MATLAB. We'll take physical problems, we'll take mathematical problems, maybe chemical, statistical. For geometrical computations, that's what we call about simulation and 3D design analysis. That's what you see when you use SolidWorks simulation, and when you use CATIA, when you use Pro Engineer, when you use Creo, and all of those guys. Those are called computational softwares for geometrical or for geometry. Like when you design a certain object as a 3D object, you got to do a certain analysis for it. You are concerned about a certain property. Then you use the geometry computational methods to be able to solve that. Then we have as well statistical programs or statistical computational methods. You know, sometimes you need to know what is the median, what is the max and min of, let's say, 1,000 products in Amazon. Like if you go to Amazon shop, or let's say in an Amazon factory, then they care a lot about statistical analysis, and they want it in real time. When they have boxes along the production line, then they want to know how many boxes being filled, how many boxes are destroyed, how many boxes delivered, all of that, to give you the big picture and one number to look at, which is good and which is bad, is done through statistical analysis, which can be considered in way or another as a computational method. You can see here, in case you're wondering, we have here the MATLAB. That's our reference computational tool that we're gonna use. We're gonna learn mainly in this course about MATLAB and nothing else. If we had a chance to expose you to a little bit of other softwares, you know, I know you have access to MATLAB and SolidWorks today, but I'm not sure if you have for Wolfram Mathematica or Minitab or other softwares. The more softwares we have access to you, I don't want you to buy any softwares, the better. So you get exposed to those softwares and understand what they're doing, even though on the surface, even doing only one thing on it, but maybe not. The main focus here is MATLAB. So if you tell me, probably Jordan is, and the other guys are more experienced with the university system, what other softwares are available for you?
Well, I really don't even know of any engineering programs that are really available for free or anything.
I asked the department, they said MATLAB and SolidWorks is available. I'm not sure. Hopefully they are.
I mean, I just haven't heard about it, so you're probably
Okay.
right.
All right, yeah. I was thinking, to be honest, to propose the Mathematica software to be the main software for this course. But industry-wise, when you graduate, when you say I have a MATLAB experience, I took MATLAB courses, which is like this course, even though his name is way far from MATLAB, but it is draining down to MATLAB. So you are learning here mainly as you are in a lab and learning about MATLAB. So try to get the best out of it, because today in the market, they are requesting MATLAB. When you put it in your resume, then you're gonna click to the algorithm and you're gonna show up better than others. They are asking MATLAB day and night every day from engineering graduates. So the more you know MATLAB, the stronger you are either in your professional advancement and as an engineer itself. Mathematica is too much kind of basic, simple terms. You would give it for a first year student probably, or somebody who's into engineering, still on the door kind of. But MATLAB, he can go simple, he can go advanced. You can, sky's the limit, you know. So since you don't know what are the available courses, softwares, I know MATLAB and SolidWorks are available. That's what I've been told. Now, we don't have today a MATLAB software, but I expect from you in the next lecture to have MATLAB. And in specific, we need to have MATLAB R. This is how they give their conventions in MATLAB. If you go to the MATLAB website, that's a good way to start. MATLAB R 2018B. That's the one we'll be using. And don't stress so much about it. If you get a hold on a copy that's older than that, that's fine. I think if you go up to 2015, you're still fine. You know, same kind of same interface, same concepts. I don't think you're gonna miss out a lot. Maybe at the end of the book you would, at the end of the course, but right now I think as a starter, whatever software version you had the hand on, Having access to it is important, but from the next lecture, I'll be sharing with you my MATLAB and asking you to share your screens and put a couple of numbers, and we'll have 2-on-2 activities and 1-on-1 activities, and let you run the codes through the software. I know you are expecting to get more theoretical parts. If you wish, we can add more theoretical part, but I think learning through doing is the best way to get the knowledge needed, especially in MATLAB, then I don't want to get you bored about text all the time, but I will highlight for you, as I'm doing now, the best bits in the book, in terms of theoretical. But like the main focus here, you get out of the course, you finish the course, you will be ready to go. You are not afraid of MATLAB. When you see it in a computer, when somebody asks you an interview about MATLAB, you know exactly what you're saying. Even if he pull a laptop and throw it on you, that's what some companies do, and he'll tell you, write me a script in MATLAB. Script is the line of code that you write to let the MATLAB do something. So he would ask you something like that. It happened with some people. Then if you know what you're doing, then you're going to do it, then you get the job. So you're expected, or we think you will be able to learn at the end of this course through the MATLAB applications. You will be able to use some simple MATLAB commands from the command window, as we're going to see. Then you'll be able to examine various MATLAB desktop and editing features, like download the MATLAB on your computer or your PC, or even if the college have PCs available with MATLAB in the engineering department, then try to log into the computer, see how it looks like, see what are the main windows, what is the command area, what is the editing area, what is the file directory, as we're gonna see moving forward. But it's not very efficient if I just give you screenshots. I will do it today, but I will not do it anymore in the future. I'm gonna share with you right away the MATLAB, do something, then I ask you do something a little different, but the same concept. So then you share your screen or post it down in the course document and look at it. So make sure everybody is able to use MATLAB comfortably. Then you will learn to write the script in the editor and run them from the editor, which means, put a certain equation like 2 plus 2. How would you write it in MATLAB? Then to give you 4. What if it give you an error? What if it didn't do it? Why? And so on. For sure, you're not going to get it done in the first time, but it's kind of, this course is teaching you coding and teaching you how to use computational methods at the same time, in specific for MATLAB. But if you, I don't know, did you guys take any coding courses before?
I have.
What's the name of the course, or what kind of software you used?
We used Java.
Java, okay. I know this course in MIT is being given, this exact course, to use Java, but I'm not a fan of Java. I would go with Python or Matlab for engineers because Java is kind of old school. But there is a C code. If you learned C code, any of you, if you heard of C code or did C code is a little bit closer to Matlab. Java is too much like, I forgot what's from Microsoft. It used to be called, I don't know, I forget about it, but like that was similar to Java, but Java kind of, I don't remember the last time I see somebody in the company or a department of human resources asking for a Java expert, unless you are a computer engineer. But like mechanical, electrical, electronics, I would say Matlab, I would say Python now is becoming a trending even for the programming students and for the computer science students. Then we learn as well, run some of the new features associated with the tabs. So when you look at the tabs in the Matlab, you will be able to look at how to publish your software, then how to create an app. Believe it or not, Matlab allows you to create app. It's not a phone app, but it's a form of app that can be dedicated and run by itself and do certain lovely things. And you can play with the user interface, make it look nice and professional. And you can even sell it to other companies and make some money out of it. So if we want to define Matlab, Matlab is a powerful technical computing system that can handle, the beauty of it, can handle scientific and engineering calculations. Like if you go to Python, you will have a hard time to implement a matrix. But in Matlab, it's in no time you can implement a matrix. And Matlab stands for Matrix Laboratory. That's what it is. So you will find matrices are very important in many engineering applications. So MATLAB is your axis between the machine and the computer. So when you are applying, like let's say you're in a factory, or you are automotive engineer, or you're industrial engineer, then you can connect between the machine and your computer through MATLAB and tell her what to do. So the MATLAB was designed before to make the matrix computation particularly easy, and that's true until today, and give it an advantage over the other softwares. Now for the Matlab Desktop, we mentioned this is the version we highly recommend to have, Matlab 2018b. If you open a Matlab website, you will find it, but I suggest on you look into your resources. I'm not sure if it's in Georgia View or other resources where you get your softwares for your other courses. See if Matlab is one of them, or if there's any engineering link. Myself, I didn't find it yet. I have my own Matlab, but I'm gonna look for it. If I found the link, I'll post it for you in the course folder as well. So how Matlab look like? You double click on Matlab, the logo that you just see. This is the logo Matlab. You'll find it somewhere in your desktop or at your start menu. You double click on it, then you will see this screen. It kind of gets confusing at first, but it is very easy. So you have your home, and you have plots, and you have apps. For the first, we don't care about plots or apps, we care about home. Then you have a couple of windows. You have this window here, and this window, and this window. The main window, that where you do your code, is called a command window. So you see these two arrows. When you want to do a calculation, let's say 2 plus 2, you want to use the language that MATLAB can understand to let him do for you 2 plus 2. Then when you hit enter, he will show you number 4. So that's your command window. That's where you write your script. Then if you don't like what you wrote here, you can clear it. There is commands to clear the screen over and over again, as we will learn. Or you can click here, clear workspace, and clear commands. There's many ways. And you can as well create a new script. Means you want to create a new program and write new lines of code to do a certain calculations. Here we have the workspace. If you create a matrix that you call it A, he will show you. If you create a variable x equals 4, he will show you x equal 4, y equal 3. Whatever you do here to let him do it, it's going to show up here. But before it will show up here, when you finish your code, as any other coding platform, you got to hit on run. So this way the code will run. If there's a mistakes, he will show it to you in red. If there's no mistakes, then he will execute whatever you asked him for and show you the results, and any matrices or variables been defined will be shown up here, like the name of the variable and the value. As well, we have current folder. Usually MATLAB will ask you what folder you want to use to save your scripts and stuff. So you go ahead on your computer and define where you're gonna, I believe while you open MATLAB, he will ask you which directory you want, and it will show up here. Like it will be C/ my documents / John / so on, you know. But sometimes when you create many apps, he will start to be confused between which folder you are pulling from, because you gotta pull data and put data. Don't be very confused if things are overwhelming right now. That's normal. Next time we will go step by step, but I would expect you download the software on your computer or have access to a computer with it, because I prefer to have it on your laptop next time for our next lecture. All right, just make sure, guys, to install MATLAB 2018b. Have that on your computer, because next time we're not going to do a lot of presentations. We're going to go right into the point. I'm going to do stuff. You're not going to keep watching. I'm going to let you share your screen and do stuff as well on a personal basis, at least until I make sure all of you familiarized with the system. And then we move with more complicated and more fun stuff that maybe you take home and so on. Just I want to make sure everybody have the software. Without it, you can't go anywhere with this course. It's a practical kind of course. And there's a final project that, there's 25 or 20% on it. At the end, it's going to be like a MATLAB project that you're going to solve. Everybody probably is different than the other one. So I want you to be prepared to that, not to be stressed about it, but I want you to be prepared and learn something out of the course. And if there's nobody else have any questions or concern, I think we can conclude. You're good?
Good. Have a good day.
All right, guys. See you next week. Have a good day.
All right. You too.